Namaskar. So let's have now the summary of the whole chapter where we'll complete our first chapter. So here we'll discuss some summary what we have studied in very brief and with some examples at the end, and that would conclude our first chapter, and then we'll move to next chapter, right? So let's have a summary part first. So what all we have studied? We have studied about empty relation, a relation R in X given by R is equal to 5, which is a subset of the Cartesian product of the set X. And we have also studied about universal relation, which is a relation in X given by R is equal to Cartesian product XX. We have seen reflexive relation, symmetric relation, transitive relation, equivalence relation, equivalence class we have discussed, which we are also trying 3 conditions. Also we have seen 3 types of function, the one-one function, onto function, and one-one and onto function. So this is all what we have studied in our this chapter, and hope you had understood. You again go through and solve more problems. For example, again we will solve some few questions here just for view that how you can solve the questions. So the question is that let R be the relation on the set of natural numbers. So what is natural number? Natural number is like 1, 2, 3, 4, right? These are the natural numbers. You should be aware of what numbers contain. Now it says that if it is defined that NRM, see this is the representation we are discussing in our previous lecture. So this can be one representation of the question. So N is related to M with relation R. So NRM if N divides M. So this is the condition. So it means NRM is equal to N divides M. Then this is the element of this is the relation, right? If and only if. Okay. Now we have to choose the correct option from here. So what all we need to check? Reflexive, symmetric, and transitive, 3 conditions, right? So let me make 3 section here. So first let's check the reflexiveness. To be reflexive, what we have to get? Let's say A is element of N, then A should be also an element of N. If it is true, then it would be reflexive. So let's check. So it means ARA is equal to A divided by A, which is true, okay, because A will divide by itself. So it means that R is reflexive. Okay. Now let's check the symmetry. Symmetry, you have to choose let's say here for every Mn element of let's say N, if M or N is element of N, meaning N divides M, then check that N or M. So it means N divides M divides N or not, right? And that should be the element of N. Okay. So see, if you show any one condition where it is not satisfied, means then it would not be symmetry, right? So let's say any number, let's say 3, 6, okay, which is again element of real natural numbers. So now if I take 3 or 6, it means what? You can write 3 by 6. And it would be what? It would be one. Let's say you write 6 or 3, okay, and then it would be 6 divided by 3 is equal to 2, okay. So it means 6, 3 is element of N, right? Now whether 3, 6 is element of A or not, so you can write 3 or 6, or you can write 3 by 6 is equal to 1 by 2. So 1 by 2 is a irrational number, it's not natural number, so it's not element of N. Now you see that for 3, 6 you have A1, R2, A2, this relation is element of M, but not necessarily that if A1, A2 is element of N, not necessary, is not implying that A2, A1 is element of N, right? So it is not symmetric. So this condition is not symmetric. Now let's say if it is transitive, So for every a1, a2, a3, okay, if it is element of natural numbers, and if it is transitive, it means that if a1, a2 is element of n and a2, a3 is element of n, then it should imply that a1, a2 is element of n, question mark, right? So this you have to check. Okay, so let's see. So let's see if I write a1 or a3, it means a1 or a2, it means that a1 divides a2. If I write a2 or a3, it means that a3 divides a2. Okay, so now check. If I write a1 or a3, I can write like this: a1 by a3. It can be written as a1 by a2. It means a1 divides a2 divides a1 into a2 divided by a3. This is true because that conditions are already given. Okay, a1 by a2, a2 by a3 divides, so it would mean that if these are the factor of that, so it would mean that a3 would divide a1, so a1 or a3 is element of n, right? It is again a natural number because they are all divisible. This is divisible and giving an integer, this is divisible giving an natural number, so the product of two natural numbers should be a natural number, right? So we will get a natural number. So it is transitive, right? So you have this correct option is D, where it is reflective transitive but it is not symmetric. So this is a very good question you can solve. The next question is about function. So let's see what we have here. So it says that the natural number set n be the set of natural numbers. Again, natural numbers means 1, 2, 3, that numbers defined by fn is equal to 2n plus 3 for every n element of n. Then check whether it is surjective, injective, bijective or none of the right. So we have to check 2 and we'll get to know if it is bijective or not, because that would satisfy the both condition, right? So let's say first if it is surjective or not. So to be surjective, what we need that if y is element of let's say n, okay, so there exists an element x, element of n, such that f x is equal to y. If this condition is met, then it is a surjective, right? Okay, let's see if this condition is there. So let's say we have fn is equal to 1. Okay, so which is an element of n, that satisfying the condition. Now if I write 2n plus 3 is equal to 1, implies n is equal to minus 2 by 2 is equal to minus 1, right? So you see that minus 1 is not element of natural number, right? So this condition is not satisfied. So if there is a fx is element of n, does not imply that x is element of n, right? So it means there is always a element available in the set n for which the image is, there is no there is a image, there is an element in y for which there is no element in the natural numbers we have. So it means that let me see like this. So we have if it is a surjective, then each element of this should have associated with some element, right? But there are some elements for which there is no element in x, so it means then it is not surjective. So this condition is not satisfied. Now check if it is and if it is not surjective, then it will not be bijective, because that should have to be both condition, right? So now B or D, we have to check whether it is correct or not. So let's say what is the condition for injective test. So to be it injective, let's say if it is fx1 is equal to fx2, okay, so it means then 2x1 plus 3 is equal to 2x2 plus 3 implies x1 is equal to x3, right? So this is the condition, right? If the two images of a given element is same, then the elements are for which they are images are also same. If this condition is satisfied, then this is injective. So we can say that this option is correct. So for this the answer would be it is injective. Okay. Okay, so this is that very brief summary and some examples just to give you a better look on how to solve this kind of problems, of course. So this is all about the first chapter. We'll see you again in next lecture, where we'll begin our inverse trigonometric functions and we'll study about that. So see you there. Thank you.